In this video, I'll be going through how to perform binary shifting, which is a question often asked in the exam. A binary shift simply moves the bits to the left or the right by the number that they give to you. There are two types of binary shifting: logical shifting and arithmetic shifting. I'm going to go through them in sequence, and I'll start with logical shifting. Logical shifting is the easiest of the shifts, and I'll explain why. So here I've got an 8-bit byte that I want to shift 2 to the right. So the instruction in the exam paper might be: perform a binary shift, logical shift of the right by 2 on this data. So all you have to do is you start 2 across, so you leave a 2 gap, and you write out this number again. Now, these ones that have left the byte block, they're dead. So they are forgotten. So when you write your actual answer, you get rid of these. In your working out section, you may want to draw it similar to this and maybe draw the box out. But you would not include this in your final answer, as that would be wrong. So what do you do with the gaps that are left? Well, in logical shifting, you simply fill any gap with a 0. And that shifts it 2 to the right. So the final answer would just be this, not including these 2 bits here, but in your working out, you may want to do that. So it is shift 2 across. So that one and that one are the same. That one and that one are the same. That one and that one are the same, and so on. I won't carry on because you've got the gist. Moving across. Now, what about to the left by 1? Well, same process. You just go 1 across. So I start here, 0, 0, 0, 1, 0, 0, 1, 0. So I've moved that across. That and that are that. That and that are that, and so on. But once again, these ones are lost. Any ones that go outside the block are lost. So that's dead. Okay, it's gone out of the block. And once again, we fill it with zeros. Now, what's the point of binary shifting, you might add? Well, it's quite an easy way to perform some simple mathematics. Because having a shift to the left by 1 has the action of doubling the number. Because if you think about it, every number to the left of the previous one is worth twice as much. So here, by moving it left to the 1, I have doubled this number. Now, this is not 100% always the case, because if you have unfortunately used a 1 at the 128, then you'll get an overflow, where obviously the 1, if this was a 1 here, you'd move the 1 out. But on some levels, you can perform basic doubling using this method. So obviously this is 16 plus 2, which is 18, and this is 32 plus 4, which is 36. So it is double the number. And the same would be said if you shifted it to the left. You could, in theory, halve the right. Sorry, you could, in theory, halve the number. So let's perform a quick right one of the number. So we start right 1, 0, 0, 0, 1, 0, 0, 1, and I won't put the 0 in there, but you can know that it's an overflow. It's an underflow, sorry, and it's gone. So that one that would have gone here, I'll just move that over in case you're really worried. I'll put it in. That one has actually disappeared. And then you fill this in here with a 0. And as you can see here, there is a slight discrepancy, because going right to the 1, you do have this odd one at the end. So in the exam, they nearly always ask you, what's the effect of going left by 1? Because whilst it does halve, it works all the way down until you go to the next one down here, where the 1 might become a 0. And as you can see, so this is 18, this is 9, brilliant, it's worked. But if we do it again, let's say we shift this one by right, we're going to get an error, because we're going to end up having that there, that a 0, that, and then we'll end up with 4, which obviously is not half of 9. And that's a slight problem with using it to halve or double a number. If this is a 1, if it's an odd number, it's not good to be halved, because obviously there's no decimal points in this system. And if you double a number and this happens to use 128, then you're going to get an overflow at this end. But that's logical shifting for you. But in an exam, they may well say, describe the effect of a left shift by 1, and you would say that it would essentially double the number. If they said 2, then you would say it would essentially multiply the number by 4. Right, So that's logical shifting. That's the easier of the two shifting. Let's do arithmetic shifting. And I'll just set all this back. And I'm going to put different numbers in because I need to demonstrate something. So, arithmetic shifting is slightly different. It's close in all but one aspect. In fact, there's only one instance where it's different to logical shifting. An arithmetic shift to the left is in fact exactly the same. It's when you shift to the right that it's slightly different. And it's only different if this is a 1. Essentially, the difference in arithmetic shifting is it's used when you're using 2's complement to try and keep the negativity of a number. Because think about it, if this was not 128, it was minus 128 in 2's complement, and then we shift it right by 2, it now becomes positive 32. And this is completely different to minus 128. So to keep the negativity of the number, use arithmetic shifting. And what arithmetic shifting does is instead of filling the gaps with always zeros, it fills it in with whatever number's in here. So let's just do it by example. So 1, do all zeros. It doesn't really matter about this end, so it was easier. They're lost as usual. But here, normally on logical shifting, you'd be putting 0, 0. But on arithmetic shifting, you put whatever number is in here. And because this time it's a 1, you fill all the gaps with a 1. And that's the way I'd sort of remember it is to try and keep the arithmetic, because that sort of word means mathematics. I try and sort of remember that logical just seems, well, fill it with zeros. Arithmetic means keep the negativity, keep the mathematical negative sign. Now, you might say to yourself, well, what if this is a 0? Well, if this is a 0, then actually you just perform exactly the same as logical shift. You are putting this number in, but it just moves over to the right. Obviously, this would be a 0. Let's make that 1. You fill all the gaps in with whatever this number is. So when you're going to the right, let's do a different one, right? I'll do 1. And I'll make this a 1 to make it more interesting. So it's 1, 0, 0, 1, 0, 0, 1, and then 0, but this is lost. And now we look at this number, and we go, right, what's this number? It's a 1, and we fill all the blanks with 1. Okay? Now, if, let's delete this, all these. Now, if you're going left by 2, let's fill some stuff in, then it's exactly the same as before. So 1, 1, 0, 0, 0, 0, 1, 1, and left, doesn't matter. You always fill these in with zeros because this wouldn't affect the positive or negativeness of it. That's how I try to remember with arithmetic shifting. I think about a link with 2's complement, and I think about the fact that I want to keep the negativity, so I have to keep that through. But on this end, you fill with zeros. So left is exactly the same as logical. Right is different if this is a 1. If this is a 0, then you can just do it exactly the same as logical because you'll be filling in with zeros anyway. But if this is a 1, then you fill it in with 1s, you go across. So this would be 0. This would be 1, 1. Fill those in. They're dead as always. And then this one, because it's right shift, and that's, you look at this number and fill in the gaps with that. Okay. So that's arithmetic shifting. Have a go at the worksheet, pause the video, and then I'll go through a couple of the answers to see if you've got them right. Okay, so let's have a look at the sheet. Got to get it up. This is the binary sheet here. I'll bring it over slightly so you can see it better in the video. Okay, so logical shifting, 2 to the right. I didn't give any extra boxes here, so you could just stop writing them because you know they're going to be lost anyway. So 0, 1, 1, 0, 0, 1, and then obviously you go back and you fill these in with zeros. So that would have been that answer. So these are all 2 across, and then you fill it in with zeros. Left, well, if I do the left and I haven't got the boxes here, I'm going to start with this bit because I moved left to the 3, so I'm going to go from right to left. So 0, which is this one, 1, then a 0, then a 0, then a 1, and then I'll just fill these in with zeros because it's logical shifting and it's always a 0. Okay, so I won't do all of them because hopefully you've got that. I'll scroll down. So let's have a look at this one. Right, so this one is to the right by 2. So I go across 1, 1, 1, 0, 0, 1. Now I look at this because it's arithmetic shifting. I look at this number. This is a 1, and so I fill these in with 1s. There you go. So that would be correct for that. A left by 3. Well, I'm going to start from the right. So I go 0, 1, 1, 0, 1. I filled that in, but because it's left, and left is just like logical, I fill it in with zeros. Last but not least, right by 1, so I'm going to start here, 0, 1, 0, 0, 1, 1, 1. So this one's lost. And I look, because it's arithmetic, I look at this number, this is a 0, so I fill the blanks with 0. So that's how to pull a binary shift and should answer all the questions you need for the exam.